Alrighty. Hi, my name is Jeremy. Let me just start my presentation here. I want to talk to you today about terminals. So if you're a programmer, you've probably encountered the terminal before. Looks like this. It's a prompt. The computer asks you to type something in, and then maybe you type something, and and the computer does something and prints a response back. And so if you've written code before, you might have written something that looks like this. You invoke the secret name of your program, in this case, hello, and the computer, your program writes something out to the terminal, hello world, the traditional incantation to the Unix demons to bless your programming career. But some terminal programs do some really wild stuff. They do colors, they do animations, they move the cursor around, take over the screen. Some of them even have mouse support. So how the heck does that work? So this talk is an unreasonably detailed answer to that question, or at least as unreasonable as I possibly could be within 10 minutes. So to really start at the beginning of answering this question, we need to go back to about 1840 and the beginnings of the electrical telegraph, which was one of the first uses of electrical engineering. So this here is a telegraph key. It's something that a highly trained operator would use to transmit Morse code over a wire. And another trained operator on the other end would listen to the incoming sequence of long and short dashes and would transcribe it as text. They would write it down into something that somebody, a normal human, could read. It was slow, it was laborious, you need trained operators on both ends. So in the early 1900s, a group of engineers pitched to the Morton Salt Company, of all things, this idea that they had for making telegraphs easier and faster to send. And so their idea was that they would hook up two electromechanical typewriters to each other. And you could just type on a keyboard like a regular typewriter, and on the other end, those characters would appear instantly readable. And so they developed this machine, and that allowed the electrical telegraph to really take off. And it was especially, starting in about the 20s, it was really used a lot by the press, by newspaper companies, and by financial companies. So that exploded. And that actually, this system kind of remained popular well into the 80s. So 50 years after the invention of the teletypewriter, this guy, Douglas T. Ross, in about 1956, was working on this computer called the Whirlwind at MIT. And this was this marvel of engineering. It took 200 people 2 years to build this computer. It had 5,000 vacuum tubes. It ran at a blistering 20 kilohertz. And weighed 10 tons, and it crashed about every 20 minutes. But it was special in this one really important way, which is that it was one of the first computers that was ever designed for real-time input. So instead of writing your commands to the computer on a stack of punch cards, putting it in the queue, and then sort of coming back and collecting the output later, the Whirlwind was designed actually for flight simulators to control dials in a simulated cockpit. Which is not what Doug Ross was doing with it, but that is what it was paid for to do. And so Doug Ross had this idea that this computer was fast enough that you could sort of have a conversation with it. You could have this real-time back and forth between computer and human. So he hooked up a teletypewriter, a Frieden Flexor writer to be specific, to the computer. This says PDP-11 on the top. They were used on PDPs as well. But he hooked it up to the Whirlwind. And so you would write a message, and then the computer would write back instead of an operator on the other end. And this worked really, really well. People loved it. And within a few years, teletypewriters were in every computer lab around the world. And people would hook them up over telephone lines so that students and researchers could access the computer from their home. So super popular. CRTs did exist at this time, but they were not used because for terminals because memory was really, really expensive. That core memory that you saw earlier was like the state of the art in RAM. Until about 1969, when RAM finally became cheap enough that you could reasonably build like a almost consumer grade hardware. So this is the DataPoint 3300, which is one of the first video terminals. So at first, these video terminals just sort of emulated the paper and ink terminals. You would type into them, and instead of the response from the computer being printed out on paper, it was just displayed on the screen. So because VTs, video terminals, displayed characters on the screen, it meant they were like a lot more flexible than a teletypewriter. So you could move the cursor around, you could delete and insert characters, you could scroll through a long document without having to print the whole thing out. It would enable this like whole new class of interactions that humans could use computers through. So teletypewriters were still popular though. So to stay compatible with the teletypewriters, video terminals used the same protocol, which was ASCII, or more or less ASCII. So the computer would send ASCII characters and they would be displayed on screen. But ASCII is only like 128 characters, and there are, so 32 and up are all printable characters, and these are the control codes that were available to the terminal for doing things that weren't printing characters, and there are only 33 of them. And the DataPoint 3300, one of the first video terminals, already used like 18 of these to do things. And video terminal manufacturers wanted to do more than 33 different things. So they used this escape hatch. The hex code 1B in ASCII is escape. And so when the terminal wanted to do something that was not print a character, it would send this escape code and then followed by a sequence of instructions that would sort of describe what to do next. So in this case, it sends escape and then square bracket 1D. And this, on my terminal at least, means like move the cursor one step to the left. So there was like one standard that all of the terminal manufacturers got together and agreed on a series of escape codes and like what each one would do. No, that's not at all what happened. There were hundreds of different companies manufacturing terminals and like hundreds of different models, and they all had different capabilities, and everyone wanted to differentiate their terminal. And so they would invent something that their terminal could do that nobody else's could do, and then they would choose whatever escape codes they thought made sense for their terminal. So in 1978, this guy, Bill Joy, was writing a text editor. And he wanted it to work on lots of different terminals. So like no matter what lab you were in, what computer you were using, what terminal you were using to access it, he wanted that text editor to work on that terminal. So he started out by hard coding tests for like, are you using a deck writer? Are you using a data point? And he would program in the appropriate escape codes to use for that terminal. But then he got sick of that, and he invented TermInfo. So TermInfo is this database of escape codes, sequences, and some other information about a whole bunch of different terminals. And it's on all of your computers right now in this directory. You can go check it out. It is actually complicated enough to describe all of these different ways of handling different kinds of terminal escape codes that it has its own programming language with like conditionals and variables and arithmetic and stuff, and like compatibility bugs. And there's a tool called InfoComp that you can run. It's at least on Macs. I think this also comes on most Linux distributions installed by default. And by default, it'll show you the information for the terminal that you're currently running. You can also ask it for different terminals. So this one, you can actually see the terminal I'm using is called iTerm2, but it has given me the information for Xterm 256 color. So my terminal is pretending to be an Xterm, even though it isn't. And here you can see clear screen is escape square bracket H, escape square bracket 2J. So if I send that sequence of characters, my terminal will hopefully clear the screen. At least that's what the database says I should send if I want to clear the screen. So the TermInfo database on my machine actually has over 2,500 entries in it, including one for the data point 3300, which I think is super cool, that my 2019 MacBook Pro knows how to control a 1965 video terminal that I don't know if any of them even exist anymore. But in case somebody hooks it up to my computer, don't worry, it knows how to drive it. Also, your computer comes with a manual on this format and a bunch of the other tools. So if you just type man TermInfo, you'll get this fully, really actually quite good description of this database and how it's arranged and how to read it. So that's you now know everything about ncurses. No, actually, there's a ton more that is not stored in TermInfo. But ncurses is open source. You can just go read the code. And if mouse info is something that's not in TermInfo. So I think that's super cool that all of this information is available and it's not beyond your grasp to know. So thanks for listening. You can follow me on Mastodon, and the source code for this talk, which is all custom, is JavaScript pretending to be ncurses. So it reads the TermInfo database and everything. You can find the code for that there. And go read some code. Nothing is beyond your grasp. Thank you.